This video is going to be on boring the block on a Toyota 22R that I'm doing for a buddy of mine. This isn't just an ordinary engine though. He bought a special kit from LC Engineering in, I think, Tucson. Anyways, forged pistons, forged connecting rods, studs, a couple of little trick things. So I'm setting up the block for boring right now. Nothing you guys haven't seen me do already, so I'm just kind of running through it. There will be a little bit more later in the video on me actually doing measuring and cutting, if you're interested in that. So this one is doing a little more trick stuff than I normally do. Forged rods, pistons, studs. Add a little more horsepower to this guy's engine. So we're going to see what it does for him, and he will be involved in the assembly part of videos that will come in the future. And this is a tool that I handmade to center the bore, center the spindle into the bore, to make sure I get a complete circle cut. I'm going to show you how to set this tool. Kind of a little run through. No, I was thinking about just doing the project and showing an overlaps of it, but I might as well show it to you. So this is it's a micrometer. This is a Starrett. It's just a normal Starrett micrometer, but it's got a special gauge here. So you're actually going to set this to you're adjusting it to your cut. So you're going to take a base cut, and then you set your measuring tool to like a set depth. So I'm going to be using my tooling's not the best. Kind of make things myself. Got a little spring that makes it easy to adjust. So then you set this in here, clamp that down. Now I just want to get an idea. So I take my T gauge, and then if you know how T gauges work, you just kind of roll it out, and then now that's set. So then I'm going to take my 4-inch micrometer, roll it out. So I know 4-inch micrometer, I'm going to have a 3-inch minimal diameter. And that measures 6, 25, 30, 31, 32, 33. So 633. That's what that bores at. So then I'm going to want to set this at 3.633. So I take, where's this tool at? Is it this one? No, it's not that one. Is it this one? Yes. That's the tool. So as you can see, that kind of springs. So I want to go to 633. Let me zoom in for you. So I'm looking on that side because that's where the 6 is. So 633. I'm just taking a standard cut just to make sure that, because I was using this, first I was using this holder for a 3-inch bore. but now I'm doing a 3.5 inch bore, so I need the bigger tool holder. See, it's a little bit longer, so I put this one to the side. I'm switching to this one. I set the micrometer for that smaller one. So I like to pry it with a fingernail, tighten it, and then there we go. So that's setting that up. So I always take it out, put it back in, set up against. So that's a 633 right there. So I put my measuring tool back now. So now I'm set up, looking at my bore, and now, if you haven't seen how I center this, look up the video that I did on boring out a Ford V10. It's one of the first videos. It is the first video I made, and I have a little tool. I made this one that goes in its place with a dial readout. Little finger gauge. I think that's what they're called, finger gauges, or at least that's what I call them. So watch that video. So you put the tool in and hold it up against, and then lock it down. It's not even you know what, maybe it is touching. It just got a lot of taper. See, you can hear that it's just barely touching it. So we got to set the tool back out a little bit because it's just barely touching the bore. Take the tool out. Put it up against. So we're going to back this off, and we're going to go, I don't know, we'll just set it back 5 thousandths. I want to get a cut. So we're going to set it to that 40. So we're at 33. We're just going to 40. We're going 40 over on this bore, so I'm not concerned about going too far. But again, that's 40 according to that gauge. That doesn't mean that's the actual dimension, and I'll show you how that's adjusted after we get a cut here. So I take the tool back out, set it there for now, And so then I'm going to get the T-gauge again. And measure where I cut on that bore. Just like that. So then I measure this, and that's at 632. I always double measure with these. If I get the same number again, then I know I'm good. .632. Now, this is when I adjust this micrometer, because this has a lock screw right here. This moves side to side. So, what I do is I loosen this. Now this moves in and out. That sets my standard. Then, if you look right over here, I'm going to set this to 632. And then I lock this back down. And again, like always, take the tool out, put it back in, double check. 632. Go in and out a few times. 632. Perfect. So now my micrometer's set. So that now, with any bore size in this relative area, I can just set the micrometer and go for it. So on this one, customer wants race parts in it. So we got some forged parts. I didn't buy them, he did. Made by LC Engineering. I always double check. But we got a piston diameter of 3.658. Let's see if they're right. 658. Look at that. Right on the dot. Now this is a forged piston, so you're always going to be running more clearance. So it's a 658 piston, but then a 661 bore. So 661 minus 658, that's going to give you a clearance of 3 thousandths, which they've got written down right here. That's like almost as much clearance as you get in a small diesel. So normally when you do a cast piston, you're going to want 1/1000th clearance. That's just kind of the go-to, whether it's an LS engine, forklift engine, whatever it is for gas. Diesels tend to be about 4. Some Cummins motors are like 6 or 8, depending on what you're doing. Sometimes even 10 if you're doing really high performance. But this case, we're doing 3 right there. So we're going to set that tool to 3.661. Now, in doing this, we're going from 3.6 to 6.1. It's a kind of a big bite, in my opinion. Yes, it can do it, but it's a little too much stress. So we're actually going to set our tool to 650. That'll put us a little bit under. So here we go, so you can zoom in and see me do this. We're going to loosen this screw, and then we're going to tighten this to to, we're gonna let it out and then kind of just lightly push it in place so that it's kind of set. Back to zooming in to 650. I go just a tad bit over, lock it down. Close enough, I don't care. 651. It's not the finished pass. So we're gonna run that 651. So I got my tool in and lock in place. Alright, that pass is done, so we're going to move on to the final. That was 3.658. So I always double check, because I'm going to make a final pass right now. Always double check the standard on that micrometer. So we made that cut at 651. So it's at 648. Not quite right, huh? So we're gonna double check. $6.49. $6.49. So we're gonna go with $6.49. Let's see what the our adjusting gauge says. 650. So I'm not gonna go adjust it over 1/1000. We're gonna hone it, so it doesn't matter too much. So we're just gonna go one more on here than what the cut I actually want. This is just, I'm not gonna be too picky. So here we go. I loosen this. So I'm gonna go 6. Let's see, that was 650. So if I want 661 as a total, but I need to leave room for honing, I'm gonna want 659. I like 2/1000. So I'm gonna go to the 660 to get my 650, 660 to get the 659. So again, tool out, tool back in, 660. Alright, and then we're gonna make this cut. This one right here is the power feed. So if I hit that in, it makes a rapid feed down. Then you put that one in, that engaged this spindle right here. That gets that turning. And then this one right here. Now we're cutting. Now see, you see this little angle right here, that's going to go down, down, down until it gets to here. Once it hits this, that little taper, that flips it out, and that stops cutting. So once you do one bore, you can set this up and down. It's got a set screw right here. So you can set that. A, it's a safety thing. B, now I can go walk away, do something, get things ready. This is another block I just did. This is for a Nissan forklift, 1.5 liter. Ain't she purty? So I can go around and do other things. And it's a loud machine, so you can hear it when it stops cutting.